Hi, my name is Grace Doyle, and I'm doing my physics project on Nikola Tesla, who focused on electromagnetism and is famous for inventions such as the alternating current motor and the Tesla coils. One inspiring anecdote about Tesla was that when he was a student, he lost his tuition money due to a gambling addiction, and he dropped out of school. Before then, he studied electromagnetism, and he would often debate his professors about the flaws of direct current or a DC motor, and some of these would include overheating and sparking of the motor, and sometimes even failure to start. He would later have similar arguments with Thomas Edison, who was actually a fan of this motor. After he dropped out, he was walking along a park, and a vision came to him about a new type of motor, which he would soon later invent, and it would soon become the alternating current motor. Below is a diagram of the alternating current or AC motor. It is also known as an induction motor. The two main parts are the stator and the rotor. So electromagnets are arranged around the outside of the motor, and they produce a rotating magnetic field, and this is known as the stator. And inside the stator, there's usually a freely rotating metal axle or coil that can conduct electricity, and this is known as the rotor. There are two electromagnetic physics laws that we need to understand in order to comprehend how the AC motor works. So the first is Faraday's law, which states that the faster the magnetic field changes, the greater the voltage in the circuit. And second, Lenz's law. The direction of an induced current is always such as opposed the charge in the circuit or the magnetic field that produces it. Now that we've talked about the laws in place, we can talk about how an AC motor actually works. Because the stator produces a rotating magnetic field, the magnetic field is constantly changing, which induces an electric current inside of the rotor. This follows Faraday's law that we previously talked about. The induced current inside of the rotor produces its own magnetic field. The rotor starts to rotate to stop the cause of the magnetic field, which follows Lenz's law. The cause of this is the rotating magnetic field of the stator. The rotor tries to eliminate the difference in motion between them. You can imagine that the rotor is spinning to catch up to the motion of the stator. Tesla went on to patent this AC motor, and it was said to be the most valuable invention since the telephone, and AC motors are still commonly used today. One modern application of the alternating current motors would be found in electric vehicles. One company that actually has this technology is Tesla Motors, and it is found in the Tesla Roadster. This vehicle has an induction motor, which is an AC motor, and more famously, Elon Musk decided to name the brand after Tesla due to this invention. Here are some of my sources, and thank you for watching.